Dr. Diaz, and since I received some questions about the content of the exam, I will explain talk a little bit about ionic equations that will be very important to understand for this next exam. Probably going to find some questions over there. So ionic equations or ionic reaction is a chemical reaction that occurs between ions in solution, as the name says. That's ionic reaction, right? So electrons will be transferred between atoms, result in formation of a new product, because we're going to have positive and negative charge ions that will interact with each other, forming a new product. And we need to show that. So we have normally molecular equations like this. Let me grab my pen over here to work with you a little bit. Hope you're seeing this. Okay. So here the equation is well balanced. So pay attention in the exam and check if that is balanced, because it's important to be balanced. Okay. So let's work with this one. If I ask you the net ionic equation or the ionic equation, so the first thing that you're going to do is total ionic, right? Oh, this is horrible. Even me, I cannot really read this. So we have ionic or total ionic, right? And what I'm going to do is look what I have. I have a solid over here, equals. Remember, to be free and the solution must be aqueous. So then we're going to have ions. If it's a solid, we don't have ions. The gas will escape from the aqueous solution unless it's a closed system. So here, aluminum will be aluminum. So I will not change because it's solid. But look at this. Now it's important to understand how the charge works, okay? So I have 6 hydrogen and also 6 bromine. I know hydrogen is +1, and I know the bromine is in group 17, so the charge is -1. That's why you don't see anything here, right, in the subscript. So I have 6 hydrogen, and there is plus, don't forget to put the state. So I have equals plus, I still have 6 bromine, -1, right? Equals, don't forget the state. And the other side, let's look to the other side. What do we have? Equals. So we're going to separate. Remember the hug row? So this is the chart of aluminum over here, and the aluminum, which is 1 over here, right? So if you don't see any numbers, 1 is the chart of bromine. And you know that bromine is in group 17, so it's easy to find out alumina is the one that is in group 13, and that asks you to memorize. Remember that it's a +3 charge. So, what you have here will be 2 of this, 2 of this, right? So it will be 2 aluminum +3 or 3 plus, sorry. What do you have here? Equals +2 bromine, -1, also equals. What about the gas? We stay as it is because remember, only equals we're going to separate, okay? That is the total ionic reaction. But a sum of the elements, like here, let's look at this side. What do you have on the left-hand side? So we have 6 hydrogen over here, right? And do I have hydrogen separate over here? No. Iron? Nope. Okay, so this will be my formula. Aluminum. It's also by itself this side, doesn't appear in the other side. And what about bromine? Oh, bromine, let's change the color here. Bromine is different. So bromine is over here and it's over here, right? So we have a bromine, and something wrong with over here. Can you tell me what is wrong over here? Look at this. 2 times 3, it's 6, right? If that is 6, this must be 6. So be careful. We need to multiply the stoichiometric coefficient by the number of the atoms. So I have 2 times 3 will be 6. So let's just fix this. Okay. It'll be plus 6 bromines. Okay, do you understand that? So like I did over here, 6 hydrogen, 6 bromine, here 2 aluminums, and here 2 times 3 is 6 bromine. So they are equal. So that is spectators. That means that will not appear in my final reaction, which is my net ionic, right? So my net ionic will be just, let me just put over here, just the yellows ones, because they are not spectators. So the other one is the spectators because they are not participating in the reaction, because the way that they come in over here, they will come out over here, okay? So let's go over here. So we're gonna have 2 aluminums, then 6 hydrogen over here, plus equals, we will not repeat bromine because it's a spectator, and then we have 2 aluminums over here, plus 3 equals, plus 3 hydrogen gas. Okay, so let's try another one, because I think we need to practice. So first thing, check if this is a well-balanced equation, right? And if it is, we can keep it going. I can see that we have 2 over here and 2 over here, 2 silver. So that, oh, sorry, I have 2 sodium over here, 2 sodium over here, 2 silver over here, 2 silver over here. I have a carbonate over here and 1 carbonate over here, 1 nitrate over here, and 1 nitrate over here. Perfect, it's well balanced. So now I'm gonna write down my total ionic equation. So let's see, this is solid, so that will keep the same way, will not separate because they are not ions. Remember what I said over here, is I make sure to bring this text for you, because that is when you have exchange reactions involving the exchange of ions between dissolved substance and water. So solid is not dissolved, okay? It's solid. That means it's not soluble, okay? So here, what I'm going to do is, I have 2 sodium, so it will be 2. The charge, so I know sodium is in group 1, right? Period 1, group 0, group 1. So that means the charge will be 1. So sodium plus. Carbonate is a polyatomic ion. I don't even need my table to see that carbonate has the charge -2. So it'll be carbonate -2 equals. Then I have this here, 2 silver. And silver, as I ask you to memorize, is one of the elements that is +1. Silver is transitional metal, but it has a fixed charge. So it's a +1. Plus, this is, oh, see? Oh, we'll not go over here. Nitrate. Nitrate is a polyatomic ion. I almost forgot to write down equals, see? So nitrate, I have 2 nitrates over here. So 2 nitrates. And since I don't have any number here, that means this is -1. I don't even need my periodic table, right? With the polyatomic ions in the back. So here I have silver and carbonate. Do I separate that? No, right? Because it's solid. So it will be the same in this side. Plus, I will put it down here, okay? So I have 2 sodiums plus 2 nitrates, -1. Again, don't forget to put equals, okay? So let's look here. Who's repeating in the both sides? So I have, oh, I raised my, so 2 sodiums over here. Who is repeating is sodium. Then I have 2 sodiums over here and 2 sodiums over here. I have 2 nitrates over here and 2 nitrates over here. So they're not participating in the reaction. So my main actors over here, what is participating in the reaction? Remember in the lab, I said, look to the main actors over here. Will appear in my net ionic reaction. So it will be CO3 carbonate, right? Equals plus 2 silver, right? Equals over here, given silver carbonate and solid. Good. This can be on the test, and I hope you understand. If you still have a question, please let me know. So have a great day, great weekend, and please study. Okay? I will stop sharing here this with you. And I can stop this. Yes, I can. Have a great day and keep studying. People, practice is the key to succeed in chemistry.